Yeah, good morning. Today I will explain how to deal the high-speed 3D machining in Fusion 360. So first you have to go to the data panel, CAM samples, and then double click on tutorial 4 to open uh, the CAD model in the design workspace. Now you can see the CAD model is opened in the design workspace. Then next is you have to save this. Then you can change the workspace into manufacture workspace. Okay, now you can see the CAD model will be in the manufacturing workspace. If you want to change the unit, you can change the unit. Okay, then first step is click the new setup, and then set the work coordinate system WCS, that is the orientation to reflect the machining plane. So click the model orientation and select Z axis / plane X axis, and then here click this vertical edge such that Z axis facing upwards. So you can see the Z axis facing upwards, and then the X axis, click this edge. So this edge represents the X axis, and you can see X axis will be in this direction. Click flip X axis, sorry, not flip Z axis, flip X axis. You can see this is the X axis, Y axis, and the Z axis. And then I will click the model. So this is the model, and then I will click OK. So setup 1 is completed. Then next is create a tool library. For creating a tool library, go to the manage tab, and then click the tool library. So here you can see in the library, left side in the library, you can see there is an option that is called local. So right click on this local, and then you can click this new tool library. Okay, when you click the new tool library, so I will name this as new library creation. Okay, new library creation. Okay, now you can see a library is created, and you can add the tools to these libraries. Just click the milling tool, new mill tool, and then you can select your cutter, and then you can change the tool number. In the post processor tab you can see the numbers. Okay, and in the feed and speed you can change the speed and the feed rates, etc., and then click OK button, such that you can add your you can add tools into your library. So I already created a library, new tool library. You can see this is the new tool library. It consists of 4 tools, tool number 10, 13, 20, and 21. So 10 and 13 are bullnose mill, then next and the 20 and 21, that is ball. So if you want to edit the tool, right click here, edit. Okay, and you can see the number. Go to the post processor, you can see tool number is 20 and the cutter is ball and mill. Okay, if you want to edit this number 10 or 13, right click here. So I will right click on tool number 10, edit tool. You can see bullnose and mill, and the tool number is 10, and you can see the spindle speed and cutting feed rate. You can adjust the spindle speed and cutting feed rate. Okay, so in this way you can add tools to your local library. So here you can see this is the local library, new tool lib1. So this is the local library I have created, and then I have add 4 tools, tool number 10, 13, 20, and 21 to this library. Okay, then I will close this. So I have created a tool library, and that tool library consists of 4 different tools. Okay, then the next step is rough using adaptive clearing. So go to the 3D option, then select adaptive clearing, then go to tool selection. So go to new lib creation. So this is my Yeah, this is my local library. Okay, new tool lib. Here you can see 4 different tools. So I will select the tool number 10, 20 diameter bull nose. So I will select this, then I will click OK. And then for the geometry, I will not select any value. Okay, then I will go to the heights tab, and then clearance height, retract both height, top height and bottom height. So I will click the bottom height and then change this to selection, and then I will select the bottom reference. So this is my bottom reference. Okay, so I will select this point as my bottom reference. Okay, and then go to the passer step, and here you can use default values, or you can adjust some values. Okay, so machine shallow areas, I will activate this machine shallow areas, and then maximum shallow step over. Okay, that is 1, and then maximum roughing step down. So here maximum roughing step down, it is 25 millimeter. I will change this value 25 millimeter. And fine step down, it is 2.5 millimeter. And then here flat area detection, I will activate this flat area detection. And stock to leave group, the radial stock to leave, it is, I will change this into 0.3. automatically the axial stock to leave changes to 0.3, and then I will click the OK button. Now in the setup, you can see the adaptive one. The toolpath is actually generating. Go to the simulate tab, you can simulate this. If you want to increase the speed, you can increase the speed. Or if you want to activate the stock, you can activate the stock also. Okay, so that is completed. Then next is rough using 3D pocket. Okay, so I will select this pocket clearing, go to 3D, and then I will select pocket clearing, and then I will select the tool, that is go to the new tool. This is my local library, and then I will select tool number 13, and then I will click OK. And in the geometry tab, I will activate this rust machining, and then use all other default values, and then I will go to the passer step, and here you can see the smoothing, this smoothing deviation. So here you can see the smoothing deviation, that is the maximum corner deviation. It is, I will change this value to 1 mm. I will change this value to 1 mm. And then maximum roughing step down, that is, I will change this to 2 mm. Change this to 2 mm. And the radial stock to leave, I will enter this value is 0.3 mm. And then go to the linking tab, the retraction policy, I will use the shortest path retraction, and then I will click OK. So in the browser tab, you can see tool number 13 pocket toolpath is actually generating 44 point. Yeah, rust rough using 3D pocket is completed. Go to the actions tab, then simulate. I will click this. If you want to see the stock, you can use this. Or if you want to see the stock, if you want to increase the speed, I will increase the speed. Okay, I will close this. So that activity is completed. Then next is machine steep areas using contours. Okay, next is machine steep areas using contours. So again go to 3D, then I will select this contour option, and then I will select tool number, go to the local library, and I will select tool number 20, and then I will click OK. Then I will select the geometry, and then here you can see the tool containment option. I will activate the tool center on boundary, and then here there is a slope option, and here you can see a from slope angle and a to slope angle. Okay, so you can enter this from slope angle as 60 degree and the to slope angle as 90 degree, and go to the passes tab. The tolerance value is 0. You can use this default value, or I will adjust this value 0.02 millimeter, and maximum step down, that is 1 mm. Maximum step down 1 mm. Then order by depth, you can see I will activate this order by depth option. Specifies that the passes should be ordered top down. Okay, so order by depth. Then stock to, I will activate this stock to leave, and this radial stock to leave is 0.1. Then go to the linking tab. Then here the retraction policy is I will change this into minimum retraction. Then maximum stay down distance as this is the maximum stay down distance. So the maximum stay down distance is 10 millimeter. So I'll enter this value is 10 millimeter, and the ramping angle. So here the ramping angle is default value is 2 degree. I will use this as 10 degree. Okay, so these are some of the default values, and I will click OK to activate the toolpath. So the third operation, that is 20 and the contouring operation. Then go to the simulate, and if you want to increase the speed, okay, okay. So in this way you can simulate this. I will close this. Then the next is the machine shallow areas using scallop. Okay, so here go to the scallop. You can see the scallop. So with the help of this scallop, you can create passes at a constant distance from one another by offsetting them inwards along the surface. The passes follow sloping and vertical walls to maintain the step over. So I will click the scallop, and then you can see select the tool. You use the tool number 20, and then go to the geometry tab. I will activate the slope checkbox, and the from slope angle is 0 degree and to slope angle as say 65 degree, and then avoid or touch surface. So avoid or touch surface checkbox. Then I will select this this flat face. Okay, avoid or touch surface. So that means select the surface to avoid. You can avoid the surface. So toolpath, stay away from the selected surface by the by the surface amount, and then go to the passer step, then tolerance value 0.02 mm, and the step over is 1, and stock to leave checkbox, the radial stock to leave 0.1, axial stock to leave 0.1, and then I will click OK. You can see the scallop toolpath is generated. Go to the actions tab, then simulate, then I will increase the speed. I will click the play button. Yeah, in this way you can simulate this scallop. Then the next activity, that is the use scallop for a finishing operation. That is the next step. Go to the 3D, select scallop, and then I will select the tool for finishing operation. That is, I will use the tool number 21. Then I will click OK. Then I will go to the passer step. Then the tolerance value, I will change this tolerance values to 0.02, and then inside outside direction, I will use this inside out option. This inside outside direction is actually the specifies if the toolpath moves inside out or outside in. Selecting the don't care option minimizes the ordering by distance. Okay, so here I am using this option inside out. Okay, so I will use this inside out. Then the step over is default value is 3 mm, so I will use this 1 mm, and then stock to leave checkbox, the radial, that is I will use this 0.05 mm, and this is 0.05 mm, and then I will click OK. So I am using scallop for finishing operation. Yeah, I will click the simulate button, and I will increase the speed, and I will click. So here you can see the scallop for a finishing operation is going on. Okay, so in this way you can simulate that one. Then next is the machine the base surface using horizontal. So here you can see, select this option horizontal, automatically detects all the flat areas of the part and clears them with an offsetting path. So I will select this horizontal, then I will select tool number 13. Okay, and then I will click OK. Then go to the height tab. Okay, and here top height, I will select this selection. Okay, top height, and I will select this so I will select this fillet here. Okay, and then go to the passer step, and then tolerance value changes into 0.02 mm, and then the smoothing deviation, it is the maximum amount of smoothing applied to the roughing pass. So I will change this into 1 mm, and then stock to leave box, the radial stock to leave, say I will enter this value as 0 mm, and I will click OK. Okay, now you can see your horizontal toolpath generated. Simulate button, click the simulate button. Okay, so here you can see this is your, yeah, that's completed. Then the next is machine fillets using pencil milling. So here I will select this pencil milling. So creates toolpath along internal corners and fillets with a small radii, removing material that no other tool can reach. So that is the use of this pencil milling. So to select pencil milling, and then I will select this tool number 21, then I will click OK. Then I will go to the passes tab, and then here you can see there is an option over thickness. Okay, so the amount of additional thickness which is applied to the tool to detect passes, the amount between the actual part radius and the actual tool radius. So I will enter this over thickness value is 1.2 mm, and the step over distance, that is the specifies the horizontal step over between passes. Okay, so the step over is 0.03, and I will activate this stock to leave checkbox, and the radial stock to leave is 0.05 mm, and then I will click OK. So now you can see the toolpath is actually generating. Then I will click this actions, then simulate. So once again go to the actions, then simulate. Then I will increase the speed. Okay, you can see that is actually generating. Then next is the finish the part. Okay, so first I will copy this, right click this pencil one, copy, right click here, and then here you can see copy, and then click the setup option, and then right click here and then paste. Now you can see this T21 pencil 2, so this is the copy of this one. Okay, and I will change rename this one parallel pencil. Okay, I will rename this as a parallel pencil. Okay, and then I will right click here, then edit, go to the geometry tab. So here the machining boundary, I will change this into selection. Yeah, I will select the boundary. So I will select this boundary. So you can see this is the boundary, and then additional offset, I will enter this value as 1 millimeter. Then go to the passes tab, then limit the number of step overs, I will disable this. I will disable this option, and then the step over is 0.7 millimeter. Step over is 0.7 millimeter, and then stock to activate the disable the stock to leave checkbox, and then I will click OK to generate the toolpath. Go to the actions tab. Oh yeah, a toolpath is still generating. So you can see in the setup tab, 30 parallel pencil 30 40%, 46, 52, it is going on. Yeah, it is completed. Then go to the actions tab, then simulate. Yeah, I will I will close this and I will select this. I will select this one and simulate. Yeah, this is the finishing the part, final. Yeah, I will increase the speed. Okay, so here, okay, I will close this. Then next is the post processing and generating the setup sheet. Before that, you have to go to the actions, then click the generate, then and generate all the all the toolpaths. So in the setup tab, you can see the all the toolpaths are actually generating. You can see adaptive 60%. It is going on. This will take few seconds time to generate the toolpath. Pocketing now 100%. Then contouring, you can see pending. Pocketing again, it is running. Yeah, it's completed. Then contouring is completed. Then scallop completed. Then next is scallop 2 completed. Then horizontal completed. Then pencil 1 completed, and finally completed. Then go to the actions tab and then simulate. Okay, again, no, it's completed. It's not completed. It's again still generating. Yeah, 56%, 72. Yeah, now it's completed. Then go to the actions tab, then click the simulate button, and then you can use the. So this is the first one, that is adaptive clearing. I will increase the speed. Okay, so that's completed. Okay, then the next step is go to the actions tab, then post process, click the post process, and then select the which type of controller you are using. So here I am using the Fanuc controller, so I will select this option, Fanuc controller, and then I will click the post button. Now your code is generating. So I will save this. Okay, so again this will take few seconds time to generate the codes, because there are so many operations, 1 2 3 4 5 6 7 and 8. Okay, so wait for few seconds. Wait for few seconds, even few minutes to generate the toolpath. Yeah, it's generating. The toolpath is actually now you can see a Visual Studio code. Okay, so I will click this. Yeah, I will click this. You can see a black screen so here toolpath is generating. Toolpath is actually generating. Again, this will take a few seconds time. Yeah, now you can see your toolpath is generated. Okay, so this is the G codes and M codes for the Fanuc controller, and the next step is you have to generate the setup sheet. Yeah, in the left side you can see 1001, that is the program name 1001.nz. Yeah, this is the, now you can see the G code and the M code. Okay, so this is your code. Okay, you can copy and paste this code in your pen drive, and you can directly connect your machine, and you can cut this workpiece in the CNC milling machine with the help of this code using in a Fanuc controller machine. Okay, so that's all about the the G codes and the M codes. Then next is the generating the setup sheet. Go to the Actions tab. Go to the Actions tab, and then go to the Actions tab, and then click the setup sheet. Again this will take few seconds time to load the setup sheet. Now you can see your setup sheet is ready. Setup sheet for the program 1001. Yeah, you can see your stock, the dx value, dy, dz value, then the total number of operations. The total number of operations is 8, and here I am using total number of tools as 4, and you can see the tool numbers T10, T13, T20, T21, etc. Then you can see the details about the tools, the tool holder, the product details, everything. Then the type of the tool, diameter or corner radius, length, number of flutes, etc. And you can see the various operations, that is adaptive 1, pocket 1, contour 1, scallop, 2 scallops, scallop 1 and scallop 2, then horizontal 1, pencil 1 and parallel pencil. Okay, so in this way you can create the CNC programming codes and the setup sheet in high speed 3D machining. Okay, with this I will stop this. Thank you.